So let us understand Kepler's third law, children. The cube of the distance, mean distance, let me write it as mean distance between sun and planet is proportional to the square of the time period of revolution. Square of the time period of revolution. So let us try to understand this carefully. So this is your elliptical path through which the sun, the planet may revolve around the sun, minor axis and major axis. Children, remember the total line is called as, line segment is called as minor axis, and this is called as a major axis. Half portion, like for circle we consider half of diameter as radius, that half portion is called as semi-minor axis and semi-major axis. So anyhow, so here we have the sun and here you have your planet. So what this says is that the mean distance from here to here, you have some line, you say r. This distance between the sun and the planets be some r. If the planet reaches somewhere here, if the planet reaches somehow here, then the distance will be some r dash. If the planet supposed to reach here, the distance between the sun and the planet must be some other, say r1. Okay, this is R1, R2, R3, and if the planet reaches somewhere here, the distance between the sun and the planet may be some other distance, say R4. At this location, maybe some R5. Like that, at different positions of the planet, the distance between the sun and the planet varies as shown, R1, R2, R3, R4, so on. So how to find out the value of R mean? The mean value of the R is taken as R1 plus R2 plus R3 plus so on, Rn upon n. Okay. So what this says is, if you take the average of all the distances between the sun and the planet, this is the average of all distances called as mean distance. So the cube root, the cube of the mean distance, r is there, so instead of r mean, let me consider it as r only. R mean here, because only one value are taking, this r mean I consider it as r. The cube of the mean distance means r cube between sun and planet. So between sun and planet is proportional to square of the time period. Time period is t, square of the time period is t square. So this is the statement, third statement. So Kepler's third law states that the cube of the mean distance between the sun and the planet is proportional to the square of the time period of revolution. Revolution means one complete revolution. So you can also write this, children, r cube is equals to, proportionality once removed, it should be replaced with the symbol equals to some constant we can replace, and this constant multiplied by t square. So r cube is equals to constant multiplied by t square. Bringing this t square the other side, we have r cube by t square is equals to constant. Whether you can say according to the statement r cube proportional to t square or r cube by t square is constant. Okay, children. So let us recall back once again the statements of all the Kepler's law. So who invented Kepler's law? Johannes Kepler's. In which era? It is in 16th century. It was in 16th century. Who was Johannes Kepler? He was an astronomer. So what he did? He formulated 3 laws called as Kepler's laws of planetary motion. Okay. So which could explain the laws governing these two, but he could not able to explain the theory behind the motion of the planets later, and this motion of the planets was described by Newton. So first of all, What is Kepler's first law? Kepler's first law says that all planets revolve round the sun in elliptical path with sun at one of its foci. Okay, so that means keeping sun at one of the focus, all planets will be revolving round the sun in which path? Elliptical path. Okay, children. So now let us also try to understand Kepler's second law. So what is Kepler's second law? The line joining the sun and the planet, sweeps out, covers equal areas in equal amount of time. So same time, suppose if you consider for 1 hour, here also 1 hour. So in 1 hour, this line covers some area. In the same 1 hour, this covers this amount of area and it was observed but both the areas are same. So same amount of time means same amount of area it covers. So now moving to the third law. Kepler's third law says that the cube of the mean distance between the sun and the planet is directly proportional to the square of the time period of revolution. Time period of revolution indicated with the letter capital T. So R cube is proportional to T square, or R cube by T square is taken as constant. Got it, children? So now let us try to understand in detail regarding the Newton's third law and how it is related to Kepler's third law. So Newton's third law is the main law which tells us regarding the force that acts on the planet, and this force is called as force due to gravity. Okay, so every object exerts some amount of force on every other object. For example, if suppose one object, let us consider some planet, exerts some force on some other object. If Earth exerts amount of force on other object, then that object also exerts equal amount of force on this Earth. I repeat, if Earth exerts some force on an object, then the object also exerts equal amount of force on Earth but in opposite direction. So this is the third law of gravitation. So now let us understand the Newton's third law of gravitation. Newton's law of gravitation based on Newton's third law. Newton's law of gravitation. If instead of object, you may get confused, I'll say that if Earth, I'll consider it as Earth. If Earth exerts some force on an object, then that object also exerts equal amount of force on Earth but in opposite direction. This is in accordance with the Newton's third law. Okay, so if you have considered Earth here and here you have considered an object, if Earth exerts an amount of force, say F1 on this object, then object exerts equal amount of force, say F2, but in the opposite direction. So these two directions are opposite. Amount of force is equal but the direction is opposite. And this goes good with Newton's third law of motion. So what is Newton's third law of motion? Says that every object exerts equal and opposite force on each other. Okay, one is called action, the other is called as reaction. According to Newton's second law, we know that F is equals to ma, children. We know that from Newton's second law, as we know that F is equals to ma, A can be written as F by M. A can be written as, taking F M other side, A is equals to F by M. Children, if you consider Earth, the mass of Earth is very large. Mass of Earth is very large. It's about 6 into 10 power 24 kg. So, because of the huge mass of Earth, larger the denominator, lesser will be the fraction. So, as mass is very large, as the mass is very large, the acceleration of the body will be less. And this acceleration itself is called as G, acceleration due to gravity. Acceleration due to gravitational pull of the earth is very less. Even the very best instrument, whatever you consider to measure the acceleration, you can't get it accurate. It can't measure accurately because of the less value. And that acceleration due to gravity on the earth is approximately taken as 9.8 meter per second square. Okay, mass of the earth is 6 into 10 power 24 kg, whereas acceleration due to gravity is hardly 9.8 meter per second square. So, the acceleration pull is very less. And one more, children, and this helps us to govern or understand the theory behind the motion of the planets around the sun. So, how they belong to that path and everything is being explained by the Newton's law of gravitation. So, the gravitational force between the planets and the earth governs the motion of all these planets, and belonging to that particular path is completely explained. The theory behind that was completely explained by the Newton's law of gravitation. Okay, children?